Let's review over our quadratic equations. Yes. I'm going to make my graph right here. Quadratic equations. So I'm going to start with the quadratic parent function. What is the equation for the quadratic parent function? Y equals x squared. What does that graph look like? Is it a line? A bunch of people in here are giving me this little like a little U-looking thing. It is a parabola. That's what I'm looking for. It is a parabola. Here is my quadratic parent function. Let's talk about a few things on the quadratic parent function. What is the vertex? Okay, in this case, it is 0, 0. On this graph, it is 0, 0. But what the vertex means is that it is the minimum or maximum point on the parabola. No problem. All right, it is the minimum or maximum on a parabola. It's the highest or the lowest point, if you want to think of it like that. You could also write, like I just said, it is the highest or lowest point. Okay? Now, another thing we learned about was called the AOS. What is the AOS? Axis of symmetry. What is the axis of symmetry? The equation will be x equals 0, but what does the axis of symmetry mean? Where the line where you can fold the parabola in half, and it is the same on both sides. So I'm highlighting it right here. That's my axis of symmetry. The equation for that axis of symmetry is x equals, and it's the x number of the vertex. Well, in this case, it's 0. X equals 0. The other thing we talked about on the parabola is the symmetric points. What are symmetric points? The points were on each side of the parabola, on the other side of the axis of symmetry, where they're the same number. Well, actually, not the same number, where they're the same distance. What number is the same in those ordered pairs? Symmetric points, in this case, with what we have, the y numbers will be the same. Okay, those two numbers right there will be the same. So in the quadratic parent function, if I had a table for it, we'd have -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. Well, where am I coming up with that? If you put y into y equals, you put x squared and press table or second graph, it would give you these points. So in this quadratic parent function, give me a set of symmetric points. -2, 4, and 2, 4. What's another set? negative 1, 1, and 1, 1. The y numbers are the same. That's the symmetric points. That's what you're looking for. In this unit, we're going to be doing a lot of comparing to the quadratic parent function. Okay? Now, there were some other things we've done with our equations. Quadratic equations are written in the form y equals ax squared plus c. So let's write this down. This is the official equation for the quadratic parent function. What happened for, we'll start with this one for example. What if I had the equation y equals x squared plus 2? Comparing it to the quadratic parent function, what happened to this equation? How did it change? This number right here, this made the vertex, it made the parabola shift up 2 units. Did it change the width? It didn't change the width, and we'll talk about that in a minute. The only thing this number at the end does is move your parabola up or down. So right here, the C moves the parabola up or down. It's positive if they move it up. It's negative when they move it down. Okay, which is the same way as the way the parabola works anyway, or when we graph any points. Okay, so that's what that last number does at the end, the plus or minus a number. Now, we could have y equals ax squared plus c. All right, so I have my quadratic parent function. What if I had the equation y equals 2x squared? But this is there, the response was it makes it fatter. This does not make it fatter. This one, if the number is bigger than 1, it makes it narrower. What makes it fatter? A fraction. Remember, y equals, like if we had 1/2 x squared. This number right here is a fraction. I told you as a hint, this is a fraction. And so it's going to make it fatter. It's going to make it wider. Okay? That number out here in front, when this number is positive, which way does the parabola open? Okay, so when this is positive, it opens up. If the coefficient was negative, if the coefficient is negative, it's going to open it downward. Okay? That's what's happening with those numbers. That's something that you have to have memorized. Make sure you have all this done because that's one of the standards where you have to know all the attributes of the quadratic function. You have to know all the things about it and be able to identify it. Questions? Now as we look at this worksheet, I think it's 6-5. The graph of the function y equals 4x squared minus 5 is shown below. And it says, what is the range of the function? Okay, I want to just point out real quick. We were just talking about what is the minus 5 doing to the parabola compared to the parent function. It moved it down. Look down here. Here's the vertex at minus 5. What is the 1/4 doing? Making it wider or narrower? Wider. Why is the parabola opening upward? Because the coefficient is positive. Okay? Now the range. The question actually is, what is the range? Underline range on your paper. Is the range the x or the y? It is the y. Okay? So I'm going to start off with y. And it wants to know what numbers are the y numbers. What is the smallest y number on this parabola? It's all the way down here at negative 5, right? And what's happening? It's all the numbers that are bigger or less than negative 5. On the parabola, are the y numbers bigger or smaller than this negative 5? They are bigger. They are bigger. The parabola opens upward. Anytime the parabola opens upward, it is going to be greater than or equal to the minimum point, which is negative 5. So when they ask you to write the range, this is what we're writing. Y is greater than or equal to negative 5. If I asked you what is the domain, it's not any other number. When they're asking you what is the range, you need to tell me y is greater than or equal to negative 5. Because you have to include all those numbers, and that's the only way to do that. Now the domain, remember domain is x. The x goes left to right. What's happening as if I continued to make this graph larger, what would happen to my parabola? It would get fatter and fatter and fatter and fatter and keep going, going, going. Well, the only thing you can do with that, because it goes to the left and to the right, it's going to be all real numbers. Okay, look at this next one. Given the range, give the range for each function graphed below. The function is given above the graph. Write the range in the box provided below the graph. Okay, so let's look at this. First off, we know range is y, correct? So I know I'm going to start off with y. My parabola right here. It opens upward. So should it be greater than or less than? Greater than, and it's always greater than or equal to. What is the lowest number on the parabola? 1, 2, 3. It's negative 5, and I also know that from my equation right there. Negative 5. So my range is everything from negative 5 and above. Number 3. Range. Range is y. The parabola opens upward, so it's going to be greater than or equal to. And what's the number that the parabola starts at? At 1. It's at constant. It's at that vertex. So it's greater than or equal to 1. Now, how is number 4 different? It's downward, so it would be less than or equal to. Yes. Y is less than or equal to. Yeah, it's always equal to because the vertex is part of the line. Okay? And at this one, it starts at 4. So again, if your parabola opens downward, it's less than or equal to. If your parabola opens upward, it's greater than or equal to. What is the domain on all of these? The domain for all of these for all of these parabolas are all real numbers. If we ask for the domain, it is all real numbers on all three of these. Right now, the question was, will it always be that? Right now for you and what we're doing in Algebra 1, yes. When you get to Algebra 2, the parabolas will lay on their side, so it will not be. Okay, but right now with what we're doing this year, they're only going to open up and down. Okay? All right, next. Okay, now I want you to take a minute and I want you to put the calculator, go and put these in there. That's one of the things you can do. Like, okay, so we'll go in here, and if you don't have your calculator, get those. Let's see if I can, what's it doing here? All right, go to y equals. I'm going to go into y1 and put in there -2 x squared, and I'm going to press graph. Oh, golly gee willikers. Okay, make sure your window settings are right at -10, 10, and you can just clear your memory when you first get your calculator. That'll make it easier. Second plus 712. Okay, you should be able to tell from the equation, but sometimes it helps to be able to see it. First off, we know that range is the y. Oh, come back, calculator. So I'm going to start off with y. Does my parabola open upward or downward? Opens downward. So is it less than or greater than? Okay, so it's going to be less than or equal to. And what is my vertex? The highest point on there is 0 because there's a +0 at the end. So it is 0. Okay, take a minute and do 6 through 10, please. Try it, 6 through 10. Okay, on number 6, you should see that the coefficient right here is negative. If it's negative, we have y is less than or equal to whatever the constant is, and the constant is -7. The next one, I see my coefficient right here. It is positive, so y is greater than or equal to whatever the constant is right there, +5. Number 8, coefficient right here is positive, so y is greater than or equal to, this number tells me my vertex, -1. Right here, wait a minute, is this positive or negative? Positive. Y is greater than or equal to -5. It's not less than because this x squared is positive. It's the coefficient that you look at for the sign. And that's one of those that you were looking at what? I mean, it's okay to ask questions. They let's see here. And to double check everything. Okay, come on, little machine. Putting in there x squared -5 and pressing graph and double checking. Looking to see which way your parabola opens. Where does it start at? Okay. The next one, y, the coefficient is negative, is less than or equal to, what's the constant? 0. That vertex is 0. Okay, so now going on to number 11. It says, use the graph at the right to answer the following questions. What is the vertex? The vertex, in this case, is it going to be a minimum or a maximum? Maximum means it's at the top. Minimum means it's at the bottom. It's going to be a minimum. So it's down here. And what is that ordered pair? 1, 2, 3, -3. And down -5. Now, it says, what is the axis of symmetry? Remember, axis of symmetry is this line right here where you fold the parabola in half. If I can draw the whatever right. There we go. I told you axis of symmetry is going to be x equals whatever the x number is of the vertex. X equals -3. Because that's that line, that vertical line. What is the symmetric point to 0, 4? The axis of symmetry, why wouldn't it be -5? Because you're folding it on this line that goes up and down. And on this line, every x number is -3. Okay, so whenever the parabolas open up and down, the axis of symmetry is always going to be x equals, because when it's a vertical line, it's x equals. When we have symmetric points, what's true, what's always the same in two symmetric pairs? The y's are the same. So I know I'm going to have something 4. So let's see, 0, 4, 1, 2, 3, 4. Well, let's see, right here. So I go over to the other side on the parabola. There's my other point. It is -3, 4, 5, 6. You should have had -6, 4. Whoop. Here's the next one. Now, if you don't have the worksheet, pause the video and see how you do. Let me see if I can move some of these questions up, though, to fit them all in here. All right. Oh, no, they're not. Okay. See if I can squish them. All right. It says circle the row in the table that shows the vertex. How can you tell in a table where the vertex is? It doesn't have a symmetric pair, but what does that mean? It's not always 0. What column would you look in? Look in the y's. Look. -10, -10. They match up, right? -5, -5. -2, -2. What's the only point that doesn't have a date to the prom? 2, -1. Right here. Circle that. That right here is your vertex. It said, how did you know it was your vertex? It did not have a partner y point, or I don't even know what other words. What can we say? You could say too that it's the maximum point on the graph too, if you went over there and looked at the graph. What is the vertex? It is 2, -1. I would also make a note on your paper, whoops, not that, that it is it a minimum or a maximum? It's a maximum because it's at the top. Remember, maximum means it's at the very top. That's a nice M there. Yes, I was being sarcastic. Axis of symmetry, where you fold the parabola in half. Here is my axis of symmetry. It's x equals whatever the x number is of the vertex. X equals 2. It says, the last part says name 2 pairs of symmetric points. So I'll put it up here and do that. 2 pairs of symmetric points. I'm sorry, what was it? Symmetric points means the y's are the same. So what's a set of symmetric points? -1, 10, wait. Yeah, -1, -10. And what? And 5, -10. What's another set? 0, -5. And 4, -5. Is there another one on here? The only thing that has to be the same is the y, not the x. Okay? Okay, on number 13, it says compare the graphs of 3x squared and negative 3x squared. Describe how the graphs are alike and how they are different. Well, I'm going to go on the calculator. I'm going to put 3x squared. Hey, let me show you a trick. If you go over here to the very far left and you press enter one time, it'll give you a darkened line for one of them so you can tell the difference between the two equations. And then the other one is negative 3x squared. Now I notice they have the same coefficient and they have the same constant. So there should be some things the same, and I heard some of you guys saying it already. There's the first one. There's the negative 3x squared. How are they the same? Same vertex. The vertex is, but on both of them, it is 0, 0. Same axis of symmetry. I heard the width. How do you know the width is the same? They are both narrow, but what's in the equation, how do you know? They're both what? They're both 3. Well, the negative, what's the only thing the negative has to do? The negative makes it open downward. So the width is the same. How they are different is because one, it's called the direction. The direction. One opens up. And the other down. Technically, we could say that they're both parabolas. They both have the same x and y intercepts. But the main thing is seeing that the widths are the same, and the only thing different is the direction, that one opens up and one opens down. Those of you with the worksheet, I want you to flip your paper over, and I want you to work through the back side right here. For those of you at home, here's the next problem. On this one right here, it says determine if each statement below is true or false. The first one says the graph has a minimum point of 4, negative 5. Minimum means the lowest point. Well, let's go over here. Let's look at 4 and down to negative 5. It is the lowest point on the parabola. This is true. True that. The y-axis is the line of symmetry. Line of symmetry is where you fold it in half. There it is. Oh, nice straight line. Fix it. Oh, I love computers. Okay. Is that the y-axis? No. This is the y-axis right here. So that is false. It says the graph has a line of symmetry of x equals 4. X equals the x number of the vertex is 4. That is true. It says the y-intercept is 0, 11. Right here is 0, 11. Is that the y-intercept? Is that where it crosses the y-axis? Yes, it is. That is true. The next one says the x-intercepts are 1, 0. Well, here's 1, 0 and 6, 0. They are not exact. The 1, 0 for sure is not even close to the line, so this is false. Here's the next problem. Oh, I missed one. Hold on. What happened? There we go. Using the graph above, what is the best estimate of the x value for which the function equals 4? Huh? Function equals 4. That's going to be where y equals 4. So you're going to go over here to find where y equals 4. It touches here and here. which is at 1. So it's where x equals 1, and it's where x equals 7. Are either of those choices down there? B is at 7. Okay, it's not always going to list both of them. They'll have one of them. The next one says determine the vertex, axis of symmetry, and one pair of symmetric points. Okay, so if you have this at home, I would pause the video and try and answer those questions and then come back and see how you do. The vertex. On number 16, the very bottommost point is right here, which is 1, 2, -3, -4. Axis of symmetry, where you fold it in half. There it is. Oh my goodness. That's why I'm not in art class. I can't draw straight lines. Okay. X equals the x number of the vertex, -3. What about symmetric points? A lot of times it's easier. It doesn't matter which ones you go to. I'll go to these x-axes or the x-intercepts because it's easier for me to see. I have -1, 0 and -5, 0. -1, 0 and 5, 0. On the next one, it asks, what is the vertex? Here is my vertex right here. It's a minimum. It's -2 and 3. -2 and 3. Now, the axis of symmetry, where do you fold your parabola in half? It's right here. X equals the x number of the vertex, which is -3. A set of symmetric points. I did use the x-axis on the last one, but it didn't touch the x-axis. So I'm going to go up here and try and see if it touches the y-axis, and it does right here and over here, which is -4, 7. And the other one would be 0 and 7. Remember, symmetric points have the same y numbers. Next, take a minute and look at your graph, and why don't you answer these questions? If you're at home, pause video and then come back and see how you do. This says, what is the approximate height of the ball when it's at its highest point? Remember, the highest point is the vertex. So the vertex is up here. Let's see, what does my line go by? It looks like 5, 15, 20, 20. So about 2.5 each one. See, because that's 2.5, 5, 7.5, 10, and up like that. So I've got 35, and then that's 2.5 more, so that's 37.5. How long was the ball in the air? Well, it started at 0, it went up, and it came back down. It landed, and it's here at 5.5 seconds. The next question says, approximately when was the ball 30 meters in the air? Well, if we go up here and look, up at 30 meters, because that's on the y-axis, it goes up, and then it comes back down, and it's back at 30 meters again. So it is 1.5, and you follow this down, and it's at 4. So 1.5 and 4. Well, why is there 2 answers? Because the ball goes up and the ball goes down. Next one. Take a minute if you're at home, pause the video, and then come back and see how you do. The first question says the ball was in the air for blank seconds. Okay, well, it started here, and it went up and came back down, and it ended at 9. It was in the air for 9 seconds. The maximum height of the ball was, maximum is going to be my vertex. So I'm going to go up here to the top. And it looks like it's about, I'd say about anything around 125, 127, somewhere in there, because it's up here in between 120 and 130, a little bit closer to 130. The ball was at 80 meters at blank seconds and blank seconds after it was thrown. Okay, 80 meters. Let's go up here to 80. It crosses here at 1 second. And over here, let's go down, and it's at 7 seconds. Now, the next question says, you got to think about this a little bit. How much time elapses while the baseball is 80 meters above or more above the ground? So if we go to 80, it reaches 80 here. It goes up, it's still above 80, and it hits 80 again. How much time has elapsed between that? So you're trying to figure out how much time this is. Well, that's 1, 2, 3, 4, 5, 6 seconds, which is the 7 minus 1. The last one, pause the video and come back and see how you do. It says the graph shown shows h, the height in meters of a model rocket, versus t, the time in seconds after the rocket was launched. From the graph, what conclusion can be made about the flight of the rocket? One, it says the rocket reached its maximum height after 2.5 seconds. All right, so here's the maximum height. Let's come down here and see. No, that's right at 2 seconds. No, that's not right, because the maximum height was at 2 seconds. At 0 seconds, the rocket was 2 meters off the ground. Well, let's see. 0, 1, 2, 3, 4, 5. Sure enough, it looks like it could be it. It's right here at the very beginning. This could be it. Let's look at the next ones. The height of the rocket was launched. The height of the rocket was 0 meters when it was launched. Well, that's not true, because 0 meters would be down here when it starts. The next one says the rocket was in flight for 5 seconds. Well, it started at 0 and it came down just a little bit after 4, so that is not the right answer. The answer should be B.